Good day. We are going to be looking at integrating today. We'll be integrating this equation or this integration expression. So when given an expression like this, we first have to look at the variables that we are given and the variables that we have to respect while integrating our expression. So first of all, we can see we have numbers, which is 6 and 2. And we have a variable. We have only a single variable, which is x. And every time when we see a variable that has a differential, which is d, that variable in this case is dx, it means we have to respect this variable whenever we are integrating. What do I mean by that? I mean the variables or the variable x is the one that will change when we are integrating. If, for example, we have a variable y somewhere in this expression, it means that variable y will not change because we do not have a differential of that variable. But in this case, we have a differential of x, which is dx, which means we have to respect it whenever we integrate. Okay, so let's move forward. How do we integrate? First of all, let's copy the first expression inside the integration expression. So the first expression, it is, or the first term, it is 6x squared. Now what do we do? Since we are integrating, we have to look at the exponent part. The exponent part of this variable that we are respecting, which is x. So x squared. To integrate, we always have to add 1 to the exponent. So whatever we do on the exponent, we have to always do in the denominator. What do I mean? Since the variable x has to the power 2 plus 1, which means we have to make sure we have a denominator that is the same as the exponent, which is 2 plus 1. So whatever we do on the exponent, we have to make sure we do on the denominator, right? So we continue and say minus 5. Okay, so in this case, 5 is only a number. But if we look at it in a mathematical manner or in a mathematical way, we know that if we have any number to the power 0, that number, it is equals to 1. It is equals to 1. For example, if we have 5 to the power 0, it is equals to 1. If we have y to the power 0, it is equals to 1. So the answer is always 1, which means in this case, we had 5x to the power 0. It will give us 5 times 1, which means it is 5. So in this case, we are safe to say where we see 5, we have 5x to the power 0, right? Then we do the same thing as we did in the first term, where we add 1 to integrate. And I said whatever we do on the exponent, we always do it in the denominator. We'll say 0 plus 1. After that, we will add all these expressions by a constant number c. So let's not confuse these ones. These ones here are just my expressions. Yes, so we add all these expressions, all these terms with a constant c. So it is just a number. This is just a number. It doesn't have a variable x. So now let's simplify all these expressions. First one we'll say is 6x, which is 2 plus 1 is 3, divided by 3, minus now 5, 0 plus 1, it is 1, all divided by 1, plus constant c, we are still not done. We have to make sure we simplify everything so that it is a simple equation. So 6 divided by 6 divided by 3, it is going to give us 2. Then x to the power 3 minus 5 divided by 1, it is 5. X, we know x, any number to the power 1, we can just leave out the 1 and just write the number as it is. So in this case, x to the power 1 is going to just be x, then plus constant c. Now we integrated our expression, the expression that we were given on top, and we integrated it as 2 times x to the power 3 minus 5x plus constant c. So the equation that you get, or the expression that you get, if you differentiate it, it means you have to get the expression, this expression inside the integral part. You see, so to verify that, we will do that in the next video, to verify that this expression will give us the expression inside the integral when we differentiate it. Thank you. We'll see you on the next video.